Everyone, my name is Stephen Kumar Kundu. Currently, I'm a PhD student at the University of Missouri, Columbia, and working as a graduate research assistant in the Dependable Cyber Physical System Laboratory. Today, I'm presenting our work. The title of our work is TruVR, the Trustworthy Cyber Sickness Detection using Explainable Machine Learning. So let's get started. So here is our outline. So first of all, I will talk about the motivation of our work. Then I will discuss the related work regarding cyber sickness detection and prediction. Then I will discuss our purpose approach, the dataset we are used for the experiment, the result that obtained from the experiment, and lastly I will talk about the conclusion and the future works. As we know that virtual reality has gained immense popularity in various fields. The field is including military training, medical training, education, and entertainment purpose. However, for the cyber sickness is one of the significant obstacle for immersive VR experiences. So users often get cyber sickness, and the discomfort or symptoms are such as eye strain, headache, nausea, disorientation, or even vomiting. So if I look at the figure here, so we can see that the user actually, she got the cyber sickness, and this actually hampered his immersive experiences. So cyber sickness detection can be divided into two categories. So one is subjective and objective measurements of the cyber sickness, and another one is machine learning and deep learning based methods. So subjective and objective measurement of cyber sickness did not provide the sufficient cyber sickness measurement during the immersion. So if I elaborate here, what happened here is like the researcher actually, they set different questionnaires such as simulator sickness questionnaire or motion sickness suspectability questionnaire or FMSQ questionnaire before the immersion, and they ask the same question after the immersion to the user, and that way they actually measure the cyber sickness. And similarly for the objective measurement, the researcher actually collect the physiological signal from the user, such as heart rate, galvanic skin response, EEG, and try to find a correlation between that signal to measure the cyber sickness. The problem is that approaches that are not automated. So therefore, there is need a lot of human intervention for measuring the cyber sickness. To overcome this problem, the researcher recently proposed machine learning and deep learning based method for cyber sickness detection and prediction using that objective and subjective measurement data. The question is here, do we need another cyber sickness detection model? So if I search just a Google Scholar like writing cyber sickness detection using deep learning, I will find more than 3,000 cyber sickness detection model. But the problem is this DL-based deep learning-based model is that they are computationally very expensive. So if I look at that figure here, so you can see that the data is acquired from the VR simulation, and based on this data, we actually develop a machine learning and deep learning model, and then we actually predict the cyber sickness. So the decision is coming here, for the detection and prediction is a black box. So there is the question is here. So why did the model make the decision regarding the cyber sickness, and does it make sense? So the reason is that there is no explainability here. So this whole decision, how they make the cyber sickness, is totally black box. And this is one of the problem of deep learning and machine learning based black box model. And another problem is like that deep learning model are not perform well for the noisy and imbalanced data. So we need a lot of data pre-processing for that. And this actually take a lot of time. And also, as I explained before, that this deep learning based model are computationally expensive. Therefore, it's not realistic for the consumer level VR headsets. So as this scenario explanation can help for the cyber sickness detection and prediction, yes, the answer, because first of all, we have to understand the behavior of the cyber sickness detection model. So the question is why and how the ML or DL model arrived at a specific decision regarding the cyber sickness. We have to figure out. And then we have to identify the most dominating feature causing the cyber sickness, because if we cannot identify the feature that causing cyber sickness, it is difficult to build a good mitigation technique. And the same thing, we have to understand the misclassification of cyber sickness detection model. So this is the first step to finding out which feature actually affected the cyber sickness prediction. So we have to find as a misclassification. And the main important part is here the trustworthy of the cyber sickness detection, that detected cyber sickness is trustworthy or not. So in our case, the trustworthiness is obtained by a set of mechanisms such as global or local explanation, where we identifying and analyzing the dominating feature causing cyber sickness. And then actually, trust to this feature identification, we can develop the mitigation method effective. So therefore, we propose a trust to the cyber sickness detection mechanism. So our detection and prediction, we have split it two parts: detection and prediction. The detection first aim is to classify the cyber sickness, and the prediction first aims to regressing the FMS score of the cyber sickness. And after the classification, we have to provide the explanation. So we provide two types of explanation. One is global explanation, and one is local explanation. So the global explanation finding the overall feature importance and the cyber sickness prediction, and local explanation aims to find out the feature importance in the individual prediction. We using it is worth mentioning here that we are using inherently interpretable machine learning model, namely EBM, logistic regression, decision tree, and linear regression. And I have to mention that EBM is a tree-based cyclic gradient boosting generalized additive model. And this is the most important thing is like that EBM is not dependent on the feature. So it is very good for high dimensional data. So for validate our proposed approach, we are using two datasets. One is biophysiological dataset, one is gameplay dataset. The biophysiological dataset contains the physiological signal of the user like galvanic skin response, heart rate, breath rate. And the gameplay dataset are basically the subjective measurement data like the user profile data such as age, user gender, user position, speed of the game. And the biophysiological data is collected from a VR roller coaster simulation. On the other hand, the gameplay dataset is acquired from a racing and flight game simulation. You can see that roller coaster simulation and the flight game simulation from the figure here. Our result is very promising. So specifically for the explainable boosting machine, for the gameplay and both the physiological data, so we obtain a high accuracy for the gameplay and physiological. So physiological, we get a very good accuracy. It's more near to 100%. And other performance metric like precision, recall, and F1 score, that's also very good for EBM for all the data set, all the other these two data set. But if we look at the other model like linear logistic regression and decision tree, the performance is quite low than EBM. The reason is that logistic regression and decision tree are always suffering from overfitting, and when the dimension of data is high, then they are suffering huge for the overfitting. That's why they have a low accuracy in contrast of EBM for both of these data set. Similarly, for the AOC RMSE curve for the EBM has very good AOC score for the both of this data set. So you can see the gameplay data set, we have the AOC score of 0.913, and for the physiological data set, we have the AOC score of 0.99 for both of these two data set. But in contrast, the other model like logistic regression decision tree have a lower AOC and AOC score and ROC score. Similarly, for the cyber sickness FMS regression, we have the root mean square error, low root mean square error, low MSE, and low mean absolute error. And specifically EBM have the good performance in contrast of linear regression and decision tree. We obtain a higher R square. So higher R square means the model is performed very well. So we have get the higher score is 0.97 for the physiological data set and 0.45 for the gameplay data set. We also provide the to validate our trustworthiness. So we provide the explanation. So here is the global explanation of the EBM. For figure 5 provide the physiological data set, and figure 6 is provide the global explanation for the gameplay data set. So we can see here that the most dominating feature for causing cyber sickness for the physiological data set is percentage change of galvanic skin response. And for the gameplay data set, the most dominating feature causing the cyber sickness is user flicker and user vision problems. So these have the highest importance in the prediction in contrast of other feature. We also provide the local explanation here. You can see that for the physiological data, the figure 7 provide the actual cyber sickness class, and figure 8 provide the no cyber sickness class. And you can see that the YOLO graph provide the cyber sickness prediction, like the positive outcome and a negative outcome, and the blue color is provide the positive outcome. So we can see that the model is predicted 1, and there is actually cyber sickness is actually 1. And similarly for the no cyber sickness, we have no cyber sickness and predicted as a no cyber sickness. And you can see that most of the features are contributing here for the figure 7 as the yellow color are contributing to the cyber sickness class. That's why the correct decision is made. And similarly for the no cyber sickness, you see that most of the features are contributing for the no cyber sickness class, and that's why the no cyber sickness class is happening. Similarly for the gameplay results, we can see that similarly that we have the most of the feature contributing for the positive outcome. That's why the cyber sickness class is obtained. And for this for that or the no cyber sickness class, we can say most of the feature are contributing for the no cyber sickness class. That's why they predicted as a no cyber sickness. We this classification, we can see that most of the class actually provide the cyber sickness, but as we see that user Jenna have no cyber sickness, much mean absolute score, and it has the probability of 0.65. That's why there is a misclassification there. So actually there is no cyber sickness class, but the model actually there is cyber sickness, but the model is predicting no cyber sickness. Similarly for that, also we can see that there is no cyber sickness, but model is predicting the cyber sickness. We have conclusion that our model is outperform all the classification regression, and we also provide the global and local expression, so identify the most dominating feature causing cyber sickness for both of the dataset. We have some limitation because we did the binary classification, so in future we have to provide the multi-class classification, and we also finally build our own dataset of where we're recruiting more participants because the dataset we use have a gender not equal. Thank you for the question. Here is our lab, so we can visit by labs. So scanning this one. Yeah, I am happy to answer any question.